Okay, good afternoon, everyone. Thank you for coming along. This is my first time at Devoxx, and it's been awesome. I'm super excited and slightly daunted by the size of the room. So my name is Moffatt. I work for Confluent. Confluent founded by the people who created Kafka. And today I'm going to talk about how you can use Kafka and something called KSQL to build streaming data pipelines. So a little bit about myself. I'm a developer advocate at Confluent, which means I get to kind of come and do cool conferences like this and write blogs and work with developers to help them understand how to get the best out of things like Kafka, and also kind of like take feedback back to the engineers and the product teams and so on. So it's a lot of fun. Before that, I was a consultant building data warehouses and data lakes and data platforms, whatever we call them with the term of the day. And I've been doing that for quite a while now, but always working in data and analytics. I like doing Twitter a lot. So if you do the Twitters, you can feel free to follow me at @armoff. And I also blog lots. I've got my own blog, and there's the Confluent one there. The slides for this, they're on Speaker Deck. Obviously, this is being recorded, and you can watch it online afterwards as well. So Kafka gets used for lots of different things by different people. So some people think of Kafka as being kind of a message bus between microservices. Some people think of Kafka as being there for simply a kind of a DOM integration point. But Kafka actually does an awful lot more than just those things. It's a streaming platform. So I'm going to start off by walking through some of the examples that people use Kafka for, starting kind of like the simplest, kind of like table stakes type stuff, and walking through the kind of things that you can actually build out just around Kafka itself. So to start with, lots and lots of people use Kafka for kind of integration between different systems. So pulling in data from databases or from flat files or whatever, and using Kafka as the ingestion point, and then streaming it on down to Hadoop or S3 or Snowflake or wherever you want to put your data. And that's a great way of doing things. There's nothing wrong with doing that. But it undervalues what you can actually do with Kafka. So you have the benefit of decoupling your sources from your targets. You can add in additional sources without impacting the target. You can add in additional targets. You don't have to rewire the sources. So it's all good. It lets you apply back pressure and things like that. But it's fairly kind of, as I say, table stakes use of Kafka. You can also do stream processing with Kafka. So this is where you start to actually take a bit more advantage of the components within Kafka itself. So Kafka has a streams API. So it's a Java library. You can build it into your Java applications and start to process your streams of data as they pass through Kafka. So let's say we're taking application logs from one server or many different servers or syslog or something like that. Instead of the traditional approach of taking the data, streaming it through, chucking it down somewhere, and then writing a bunch of jobs to pick that data back up and process it and look for certain conditions, like errors, for example, we can actually do that as it passes through Kafka. So you can take your data as it passes through. You can either filter it just for those conditions, or you can actually split it and say we're going to create the target with the full data set as we wanted before, but we're also going to populate a separate target just with the errors. So we actually get a lot of benefit from doing that processing within Kafka itself. We can also use Kafka for actually doing more than just filtering data. We can use it for enriching streams of data, for denormalizing data sets. So let's say we're taking data maybe from a relational database, it's underpinning our orders application or whatever. We're streaming that data through Kafka, we want to land it out to somewhere else. But let's say we're putting it to Elasticsearch. Elasticsearch, fantastic tool, I love it, but generally it wants your data denormalized. So you can use Kafka to do that. As the data passes through Kafka, we can start to denormalize down our facts and our dimensions. From the database, we've got our orders table, we've got our customers. As our orders are being placed, we can be enriching them with the information about those customers. And the benefit of doing this, again, using Kafka, is that you benefit from the decoupling. Because today, maybe we're using a database with like a big hairy monolith sat on top of it, populating it, but maybe we decide to break out our order processing into a microservice. So then we say, well, now our order events, instead of coming from the database, now they come from a microservice. But our customers still sit in the database, as where customer reference data almost always does and will. So now we can take our order events that are coming from our microservice onto a Kafka topic. We can enrich them with information about those customers using the stream processing in Kafka, and then write that down to wherever we want to write it to. Another point of using Kafka is that Kafka persists its data. You can define per topic within Kafka how long you want to keep that data for. You can even keep it forever if you want. It depends on the use case of that particular set of data. But it means that you can actually enrich that data once as it's passing through, and you can use it multiple times. So perhaps we're populating an operational dashboard or whatever it is with our orders information over here for our customers, but down here, we've got a new microservice that we're also building out that needs to know about when new orders are placed. Maybe it's responsible for sending acknowledgements or shipments or something. It needs to know about who's placed an order or an order's being placed and who placed it. So it also needs that enriched information. So we process it within Kafka, we write it back onto a Kafka topic, and because it's persisted in Kafka, we can use it in multiple independent places. We can also write it down to Hadoop and S3, as we always have done for kind of longer-term audit and analytics and batch-driven analytics as we want to. So let's see an example of this in action. It's based around a similar concept of streams of events coming in. In this case, the events are events from a website. It's ratings information, review information. So people are using the website and they leave reviews about the products. They say, this product's brilliant, or it sucks, or it's awful. And the people leaving those reviews, they're users, they're customers, and that information sits in a database. So we're going to see how we can have that stream of events, and we can combine it with the information, in this case from the database. We're going to bring that information into Kafka. We're going to use stream processing to enrich it, and then we're going to do several different things with it. The simplest thing we're going to do is simply say we've got a stream of events happening in our business. We want to drive that onto a real-time dashboard, an operational dashboard for our customer team. So they can see what kind of ratings are being left by which kind of customer, do a bit of analysis on it and see kind of like the trends of information in real time. That in itself is kind of pretty useful. We're also going to chuck it into the data lake, because that's what you do with data. You chuck it into a data lake and forget about it, or being slightly less snarky, you put it into a data lake and use it to drive your machine learning training, you use it for your batch analytics, whatever else you want to do with it in kind of like the longer term. But we're also going to use that data to drive some real-time actions. Because that information about users leaving reviews is actually kind of useful, and we can do some good things from that for the business. Instead of simply saying and kind of observing what's happening to our ratings and user satisfaction, we can say our users who have got a kind of a membership club, so they have bronze status or platinum status, if our really important users start leaving bad reviews, we want to do something about that, and we want to do something about that now. Rather than kind of chucking it in the data lake and next week analyzing it, and next month the data science team saying, oh, there's a kind of correlation between really important users being unhappy and them never coming back. And they spent lots of money and now they don't. So we could actually do something to fix that. We could say, well, let's take that rating information that comes in, find out the kind of user it was. If they're a super important one, let's actually send a notification to that operations team, say this really important user's just left a bad review, let's phone them up now. Let's actually do something about it. And we're all customers, we all buy things, we all know next week's too late. We had a bad experience, we're gone, we'll go somewhere else. But something goes wrong and someone phones us or sends us a chat message or something, says, we can see something just went wrong, can I fix it for you now? That's much more likely to have an immediate effect. So it's this idea of using events to actually drive lots of different processes. So we're going to build it out. We've got our application over here. It's using the Kafka Producer API to stream those events, to stream those rating events down to Kafka. We're using the simple Consumer API to do the push notifications. All the code for this is on GitHub, by the way. It's a nasty bit of Python. I'm not proud of it, but it does the job. Takes a Kafka topic. If there's a message on it, shoves it out, in this case, to Slack. And now we're going to see how we can actually use another part of the Kafka ecosystem called Kafka Connect to actually integrate other systems into Kafka. So where we've got our ratings application up there, it's our custom application, it's producing custom events, that uses the Producer API to get the data into Kafka. But over here, we've got a database. Databases everywhere. And databases have got data that we're going to get into Kafka. So rather than writing our own program to do that, which is a horrible idea, use Kafka Connect. We've got data that's sat in Kafka that we want to shove over to Elasticsearch, down to S3, to HDFS. Don't write your own code to do that. It's done for you already. It's called Kafka Connect. So Kafka Connect gives you this ability to do streaming integration from different types of sources, loads of different sources into Kafka, and from Kafka down to different targets. So it might be you've got your own applications populating Kafka and doing processing, but that data in the Kafka topic you want to land somewhere else, use Kafka Connect. It might be those applications need to be fed with data from somewhere else. Use Kafka Connect to get that data in. And of course, you can build end-to-end pipelines with it as well. Pull in data from over here, through a Kafka topic, and out to a sink over there. So Kafka Connect runs separate from your brokers. It's a separate JVM process. It's built on top of Kafka, so it scales out. It's fault tolerant. It also does really good things like handling your schemas for you, which are super important. To find your connectors, you can go to Confluent Hub and download them there. Find the different technology you're interested in, type in the search, and download the connector. OK, so let's have a look at a demo. In this case, we're taking data from our database, which is MySQL. It could be any relational database. The concepts are the same. So I'm using a tool called Devoxx, which is a change data capture tool. It's brilliant. It's open source. It takes the MySQL bin log, and it streams all the transactions from the database into a Kafka topic. OK, so here's MySQL, and we've got a bunch of tables in it. Well, we've got one table in it. We've got customers. And on our customers table, we've got some customer data. It's just a database. We've got user IDs, we've got customer names, we've got our club status over here, which is what we're interested in. What kind of user are they? They're bronze, platinum, and so on. And they've got a user ID over here, which is going to be our foreign key out to the key on the events that are coming through. Now I'm going to switch over to KSQL. So KSQL is something I'm going to talk about in more detail in a moment. At this stage, I'm just using it to interact with my Kafka topics. So I can say list topics. Show me what topics there are on my Kafka broker. And it says on your Kafka broker, you've got a bunch of different topics. And we've got one here called customers. OK, so let's have a look at the topic. Print customers from beginning. Kafka persists data. We can look at all of the data from the beginning. And we get a bunch of data. OK, so we can say, let's have a look for user ID 1, who's up here. So it says the topic is in Avro. It's got a timestamp. And there's Rika Blaisdell. If we go back to MySQL, is our first user. So we've got a Kafka topic that's populated with the contents of a database table. It's bootstrapped that Kafka topic with the contents of the database table, which is useful, but it gets better. So if I split the screen here, OK, let's resize that. So over here on the right-hand side, we've got my Kafka topic. OK, it's not showing the command prompt yet because it's a continuous query. It's showing any event that lands on that Kafka topic. And over in MySQL here, what we're going to do is we're going to change the status of a customer. So we're going to update the table. OK, update customers, set club status equal platinum, where ID equals 1. So we make that update there, and straight away in our Kafka topic, we can see we get the new message through. So you can take changes from the database and stream them into a Kafka topic. You can insert new rows. OK, so we're going to insert ourselves a new customer. Mr. Rick Astley joins the organization. Over here, we get the new record over here in our Kafka topic. So not only can you bootstrap what's in the database into a Kafka topic, you can mirror what's happening in the database driven by manual inserts or whatever application interfaces with the database out into a Kafka topic. And we're going to see how that translates into stream processing in a moment. OK, so we've seen how we get our data in from a database into Kafka Connect, into Kafka. We can use Kafka Connect in a similar way. It's just configuration files. It's just JSON configuration files that you set up. So I said, there's my database, stream the data in. I can also say, here's my Kafka topic, stream it out to that Elasticsearch. And it just, off it goes and does it. Now we're going to see how we can do stream processing. So I said earlier, there's the Kafka Streams API. And that lets you actually do stream processing within your Java applications. But not everyone writes Java, or not everyone wants to write Java. So for that, there's also something called KSQL. So KSQL is a declarative stream processing language, and it's the streaming SQL engine for Apache Kafka. So what it lets you do is use SQL to build stream processing applications. It is super powerful. So we're going to see it in action in a moment, but if you can express what you want to do with your data in SQL, you can write a stream processing application. There's no kind of like boilerplate stuff around it that you need to put in. It's just SQL that you paste. So to start off with, you can use the user interface, or there's a REST API or a command line tool to actually prototype the kind of queries that you want to run. So you can use KSQL, just like I showed you a moment ago, to actually just have a look at the data you've got flowing through topics. We're going to see how in a moment how you could actually take a topic, register it with KSQL with a schema, and pick out certain columns or certain rows. And then you can actually start to build out transformations. Filter this data, aggregate this data, join this data, and populate Kafka topics continually with the results. So not only does it take the existing data that you've got in your Kafka topics and process it and write it to a new one, every new message arriving on those Kafka topics upstream gets processed continually and written downstream. It's a stream processing application that you build just using SQL. So you come up with your SQL statements that describe what you want to do to your data, you prototype them in your development environment, and then you work with a SQL file. And that SQL file is your code that you pass through into production. So KSQL servers, the JVM processes, you can run one, you can run many scaled out for performance and for resilience as well. Okay, so let's do a simple demo. So now we're going to start off just by taking that ratings information. So up here we've got our ratings data, it's flowing through. We've got a Kafka topic with data landing on it. Where it comes from, whether it's producer API or Connect, doesn't matter. It's just a Kafka topic with data. I'm going to start off by creating a simple derived topic from this, saying all these ratings that are coming in, let's filter them out just for ones which aren't very good, for poor ratings. So the ratings of a star system, 1 to 5, 5's awesome, 1's not awesome. So anything less than 3, we say it's a poor rating, it's not very good. And that's going to drive additional analytics downstream. Okay, so back to KSQL and over to my cheat sheet. So here, the first thing we do, if I say list topics, we can say we've got a topic here called ratings. So for KSQL to actually be able to work with it, we need to know the schema for that topic. We need to register it as an object in KSQL as a stream. Because I'm using Avro serialization for the data, the schema actually already exists. The schema's in the schema registry. So all I need to do is simply say create the stream against this particular topic, and it's an Avro. I've not had to tell it which columns, which is a great reason for using Avro. So now I can say describe ratings. And it says, OK, you've got a KSQL stream, and it's got a bunch of columns. So now I can look at those columns and actually interrogate the data. So we can take that data, and we can say, let's select the stars and the channel and the message from ratings where stars is less than 3. It's just a SQL query, but it runs continually. So KSQL is a continuous query language. This is not running against a relational database. You run the query, you get a bunch of results. Has the data changed? I don't know, I'll rerun the query. KSQL is a continuous query. So this is a live stream of my Kafka topic. Every new event that's coming in, it's filtering it in real time, and it's showing me just those columns I asked for. So we're actually filtering down the contents of the message and just picking out particular fields. And we're also filtering out the messages themselves and just ones matching a certain condition. So hopefully you can start to see some of the possibilities with KSQL. You can actually say of these messages, of the message contents, just take certain fields. You've got a bunch of information arriving with personally identifiable information in, plus other stuff you're interested in. PII data is sensitive, we don't necessarily want it. Just select the other columns into a new topic and off you go. It's just a select statement. Okay, so that's echoing to the console the results of that query, which is kind of like interesting. We could watch it go by all day. Some people have seen this demo before and pointed out there's no correlation between the rating, 1s and 2s, which is negative, and the messages, which are like in some cases positive and some cases not. So that's just a flaw in the test generator. Okay. So we've got the data, it's flowing onto the screen. Much more useful is to actually persist it to a Kafka topic. And to do that, we simply use create stream as select. So if you're familiar with databases, you have create table as select, creates a new table, copying the contents of an existing one or subset of the existing one. Here we say create stream as select. So we're going to create a stream with the results of the select statement. So we literally just put the prefix on here, create stream, poor ratings as. Now it's off and running. Our stream's created, it's running. We can describe it. So describe poor ratings. It's got a schema. It's got fewer columns because we selected just those particular columns. And describe extended under the covers shows us, if we page up, that it's a stream. I'm going to talk about tables in a moment. And it's writing to a Kafka topic. It's using Avro because we're good people. It's got a schema. It's got a query that populates it. And it's got messages flowing through it. It's an application. It's got metrics. If we read on that, It says you processed more messages, 42 by lucky chance. So the messages are flowing through. They're coming in on the source one. We're filtering it in real time. That select statement's running. It's writing all of those messages that match that to the target topic. How do we know it's writing it to the target topic? Well, let's have a look at the topic. Again, from within KSQL, you can look at a topic itself, print per ratings, and here's the contents of the actual topic that we're writing to. So you can see stars 1 and 2, just the fields that we wanted, just the messages that we wanted. Now, we're going to do something a bit fancier. Now we're going to actually start to denormalize this data down. So we've got our events flowing in, we've filtered the events if we want to. Now we're going to take our information about our customers and join that to our events. So as each event comes in, each event has got a user ID, which is our foreign key, out to our users. The user information we have in a database. And we've seen already we've got a Kafka topic that mirrors what happens in the database. So when we do stream processing within Kafka, we're not going back to the database. That's a nasty way of doing things. Instead, we're saying we've got data in the database, we will mirror it into a Kafka topic, and we do our stream processing against that. So we're just going to use a SQL join statement. But to do that, what we need to do is model the data as a table. So there's something called a stream table duality, which is not something I'm going to go into at length here. But the stream table duality is actually a thing. It sounds a bit fancy. It's on the Confluent website. There's a really good explanation of it there. And what it is, it's a way of modeling your event data. So we're actually going to work with a stream of events. If we remind ourselves what the topic, the customer's topic looked like, here's our customer's topic. It's a stream of events. And that stream of events was populated by changes in the database. But what we're going to work with in our stream processing in Kafka is a stream of events. So within KSQL and within Kafka streams, you have the concept of a table, which simply says, from a stream of events, I want to know what the state of a given key was at a point in time. So it's driven by the topic. It's a way of reasoning about the data as a state. So we're going to take our stream of ratings events and model it as a stream, which is what we have done, and we're going to join it to our table, which is a stream of database changes modeled as a table itself. So let's see that itself. So to start with, I'm going to show you the stream of customer events. So here we're creating stream within KSQL, so it's modeling it against the Kafka topic up here. There's our customer's topic. We've not had to define the schema because it's Avro. So now we can say, let's select information from this stream within KSQL. So our stream of events, where ID equals 1, okay, it's a predicate, it's SQL, for ID 1, for that key, is 2 events. First, Rika Blaisdell was bronze, and then we ran the update, and she was platinum. If I run another update, okay, let's go back to my SQL over here, and set the club status. Oops. That's the problem with doing live demos. Okay, so we changed that there, and it's not going to work because it's a live demo, so we'll leave that be. But as the events happen in the database, they get mirrored through into the Kafka topic. That always works except when it's live. So we've got a stream of events. It mirrors what's in the Kafka topic. And now we're going to actually show that as a table. So we're going to create the table, and the create table simply is a construct within KSQL to model that data in the topic. So it's coming from a Kafka topic, and we've defined the key for it. And now when I say select from that customer's table, in KSQL, it's taking the Kafka topic, and it's showing the state for that key. And the state for that key is 1. Sorry, is platinum, okay? Let's have one last chance, one last go at this. Okay, let's change it to bronze. There we go. So now, in the table, the state has changed to bronze because we've re-emitted the state because the state has changed. It's a continuous query. You'll notice we don't have a command prompt here because it's a continuous query. The select keeps on running until I hit cancel like that. If I rerun the select, it's going to say, what's the state of that table at the moment for ID 1? And the state is bronze. Okay? If I rerun it and push my luck, platinum, and we go back, we see it's platinum. Okay, so what's happening in the background is the database changelog going through Kafka Connect, change data capture onto the Kafka topic. The Kafka topic is back in that KSQL table. It's a way of modeling the data and reasoning about it. If we rerun that against the customer's stream, okay, this is customer's stream, you see all the different events where ID equals 1. So it's the same topic underneath, it's just a different way of reasoning about it. Okay, so now let's join it. So we're going to join it. We're going to get a screen full of information because I've actually set the offset back to the beginning of the topic. So all that ratings data that's been running since the generator's been going is about to fill the screen, but with joins against it. Okay, so it's whizzing by and it'll slow down in a moment because it'll catch up with actual real-time events. But if I pause that, you'll see here we've got the rating ID, we've got the message, and then we've got the user and their status. So each event that's flowing in is being enriched. Each event that had flowed in is being enriched with the customer information, and it's put on the end here. So again, we can persist that, create stream as select. This is now creating a Kafka topic and writing the results of that select to that Kafka topic. We can take the Kafka topic, and we're going to create another stream called unhappy platinum customers, which from the name implies it's customers who are platinum status who are not happy. They've left a negative review. So this creates another Kafka topic, eagle-eyed here, value format JSON. We're actually writing a Kafka topic in a different format. So with KSQL, you can choose, I want to use Avro or JSON or delimited if you have bad ideas about data form serialization. And now we can say from Kafka Connect, it's taking that Kafka topic and it's streaming it out to Elasticsearch. So in Akibana dashboard, which is a nice visualization tool on top of Kafka, you can actually see the results of those enrichments. So you can see the ratings themselves are flowing through. We can break them down by the device by which they were left. Then we can also see by club status, what's the medium rating, the full ratings details, and then you can see here the unhappy platinum customers. And since I'm having such luck with the live demo so far, I'm going to push it even further and see if this will work. It wasn't earlier, it crashed, I had to restart my iPhone. And in this, it should be able to mirror the screen. Let's give it one quick go. No, it's not playing ball. That's the problem with live demos. But if I hold it up like that, you can see it afterwards. It's Slack notifications pushing through onto my phone. So just showing the idea that you could actually use this data that's flowing through from the events to actually drive push notifications, as well as driving the kind of real-time analytics as well. So we've seen what you can do with KSQL. We've seen how you can do filtering, how you can do joins. You can also do aggregations. So you can do stateful aggregations within Kafka streams, within KSQL. So you could use that to say what how many ratings have been left by club status, and you can actually use that with a predicate. You could say if a certain number of ratings of bad quality are left within a 5-minute window, something's gone horribly wrong, everyone's really upset, so let's do another push notification. So it's really simple to build this kind of logic into your pipelines. So all of this is built on Confluent open source. So you've got the schema registry there, which holds your Avro schemas and provides the serialization and deserialization. You've got KSQL there, which is what I've been showing you, the SQL stream processing. You've got a bunch of connectors, and obviously got the latest version of Apache Kafka as well. There's a ton of free books that you can get off our website. If you're interested in knowing more about Kafka and some of the specific principles behind it, you can scan the QR code, you can go to our website. The slides will be online afterwards as well. I'd really appreciate it if you rate the session in the app. It's really great feedback always to get. And finally, visit our website. You can get KSQL from there. That's my Twitter handle, my email address. Send me any questions. I'll be hanging around afterwards. There's a really good Slack group. There's about 7,000 members now, which is awesome, and a bunch of different channels for all different subjects around Kafka and the Confluent platform. And then if you're interested in more kind of architectural stuff around Kafka, I'm doing a talk tomorrow at midday in room 5, so come along to that as well. Thank you very much for your time. And before you all disappear, I'm going to try and do a quick speaker selfie, if you'll forgive the indulgence, if I can actually operate my phone this time.